Okay, I guess we're alive. Uh, Today was not like our usual schedule, which would be I guess 4:30 GMT. Today we're starting at 6 p.m. GMT, also with 5 minutes of delay. So sorry about that. Anyways, let's continue on what we did yesterday. We were trying to finish our render, our draw method, our draw member function, and we decided to add these interfaces for now to command. Of course, this is not going to be our final interface, as we decided yesterday that we are uh, we actually need a radical redesign, and that is what we are going to do later on. But for now, I guess this is what we're going to implement these, which I guess I'm going to also keep these in my new design, but again, who knows. So the way I'm going forward is just I'm seeing the new code, I'm trying to implement new features, and implementing those, I realize that I'm missing some part of the design, or either that my design doesn't suit well to is not a good solution to my requirements, and then I reiterate on my design and I change it and I go forward till I see new cases. Uh, so in this iterative method, I will be reaching to some point that I would say is good enough for me. It's a good enough generic interface for my use. So that is the plan for now. So yeah, I'm going to start implementing these interfaces for my command, and the requirement for that arises from here. Also, I'm going to, yeah, I will have to provide this interface as well. So there's one inherent design flaw here, and that is that this vertex count and that offset, these should be kind of part of the vertex buffer that I'm binding, yet they are not. So that is the same thing that arises. Let me see here. I guess where is it? Where is that? We have stride. Let's search for a stride. No, it's strides. Really? Okay, yeah, that is. So this is some some data that I would rather be in my vertex buffer, but it isn't. So if I go ahead and change my vertex buffer in the future to something else, I would have to come and change this as well. So I believe this vertex buffer stride, the vertex buffer itself, number of vertices, and the offset. These should be one single object. But for now, let's just provide these interfaces. Yeah. Like I'm imagining something like I would put these in one single object, like an entity in my engine, and after then I would just tell the command to draw that entity that would do all these. But anyways, let's just get to it, I guess. I'm redoing whatever modifications I have done. Okay, I believe that is the correct modification. We do not need this. Anyways, let's get back to our draw again, and let's just implement this. Okay, find vertex buffer. What is it going to need? Needs buffer count, which is going to be 1. So it is doing a for loop inside. I mean, why would you even want to provide this interface to the user? Command list IA set vertex buffer count views. That is interesting. So what I'm trying to figure out here is whether I actually need to provide an interface for multiple buffers as this is doing, or should I just be like a single buffer would be enough? I guess there are performance reasons as to why they have done this. So I guess I'm going to provide the same kind of interface, and that is going to be, I guess, I'm going to take some kind of container, which is going to be uh, VBO containers. Let's say this is probably vertex buffer container type. Okay, and what else do we need? That container is going to contain these. Then we need stride and of course a pointer to stride. That is kind of weird. That is awfully weird. If I know anything, if I remember anything correctly from OpenGL, I know that they took stride as a pointer, as a void pointer, I believe, an offset. And you can see that the offset is as well a pointer that is null. So it makes me wonder, is this code correct? Maybe this should have been, let me check this. It is actually a uint PDR. Let's get into this. Let's see where this stride is used. Oh, so that is a stride per buffer. That is what that is. And that is an offset per buffer. Okay, that makes sense. He provides null here. He provides null just to say that set all the offsets to 0. Okay, I can understand that. But how do we actually implement this? Problem I'm having here, if I were to, like, this interface sucks in that manner that if I want to actually implement this, I would say that these are a single object. Alright, so I'm going to have an array of these objects, so then I wouldn't have my strides or my offsets in one contiguous memory. They would be broken up. So either I would have to as well just take 3 containers, one for vertex buffers, one for stride, and one for offsets. Or I would have to reconstruct these pointers from my uh, vertex buffer container type. So that is a dilemma there. Let's Let's finish these first. These are the easier ones. So bind descriptor set is just getting a descriptor set and index, and it just binds it. So that is going to be easy for us. Just a simple call. Let's see what parameters this takes. Okay, we're going for command footer. If I remember correctly. Yes, I do, but I didn't type it correctly. Where were we? Command footer dot get. That is our command pointer, and we're going to pass the descriptor set. I guess the index comes first, as I remember from their convention. I don't know why, but that is the case here. Okay, that is done. Same goes with the draw. Draw is easy as well. Command draw, and soon we will be back to our main problem here. Command pointer get, and we're going to pass it the vertex count, which I believe still has to be offset. I believe this and offset is part of the vertex buffer as well, but if you bind in several vertex buffers, what is this draw going to do? That's the question here. That is kind of weird. So yeah, that is one thing to figure out. What does the draw function do if multiple VBOs are bounded? I guess they're going to be bound into one single shader. I believe I've seen such a thing, but like you would put your normals in one VBO, your vertices in another, and of course your UV in the third one. That could be the reason that feature is available here. That could be. But again, here I would like my code to be like this. Alright. We have that, and this is going to be our vertex buffers. Okay, in my view, that is the code you want to see. Like bind vertex buffers, alright? Let's put an S there just to say that we are binding several. Bind vertex buffers, I'm assuming it just takes vertex buffers. Why would it need to take anything else? So that is the proper interface for bind vertex buffers. It is just going to take whatever that can contain multiple vertex buffers. That is the proper way of doing that. But again, if I were to call this function here, I would need several of these. And how would I do that? I'm assuming I don't know. I don't really know what to do with this. Like if they were to actually expose this type, I don't know what this type is, but this is the proper type here. So they have proper interfaces here, and then they break the interface into three pieces of buffers, piece stride, and offset. This this isn't going to be cache friendly either. This is not going to be cache friendly either. Why would they not just expose this view? I don't know whatever the type of this view is. All case. Define here, declare zeros. vertex buffer view. Huh? What the hell? How did I get to where I was? So that's one design question I would have. What the hell is just happening? Intelligence operation progress, are you kidding me? Now that is one design I would definitely question. Declare zeros. What is the type of views? What does this declare zeros do? Type and variable. Okay, I believe that is the type then. Where is this type? That is. Come on. Come on, Visual Studio. Don't give me that. Like, really? Back to here. Let's find that. Let's pin this one here. What that? I'm searching for this. I have no clue what type of view is here. Anyways, and they're supporting maximum of 15. Max vertex attributes. I can use that. I definitely can use that. My question is that part of their interface? Am I allowed to use that? That is the question here. Default capability level. I guess I'm able to use that. I guess they provided as an interface. So that makes my life a bit easier here in my interface. So I'm going to do the same thing. The same thing that actually Direct 3D has done. I don't know why they're just avoiding it. Let me see what the let's see what the wool conversion does. What about that? Let's see what the wool conversion does. The wool conversion, piece stride offsets, buffer 64? What is that? No upper bound for this. So use 64 for now. Is there not a maximum buffer for them? For VUCA? Let's check this in wool conversion. There is one. Where is it defined? I render. So that just became weird a bit. So let me see. They're taking these buffers and offsets or whatever else that there is. They're declaring 0. This could be not accessible. What kind of code is that? Offset 64. That is undefined behavior right there, isn't it? Am I wrong, or is that actually undefined behavior right there? No upper bound for this. What does that mean? Oh, alright. They're just oh, they're shadowing there. Oh yeah. Oh, that's my mistake there. DK buffers. Alright, that's my mistake. So Yeah, I was mistaking these variables to these. These are not the same variables. The names are pretty close, but they are not. Anyways, they're declaring zeros, these buffers, and offsets. So their interface is much closer to Vulkan's interface, which takes buffers and offsets separately. What about the strides? What are they doing with these strides? What do they do with these strides? They don't use the strides? Is that correct? They just ignore the strides? Let's check this. Vertex buffer strides in Vulkan. That is interesting. So they're using the strides in the D3D version, but they're just ignoring it here. Unref param. Then why are they asserting it? And what is this unref parameter? What is that? Oh, God knows what that is. Let's see if we're actually passing strides to our vertex buffer itself, because if that is the case, we wouldn't actually need to use it there as well. Let's see. So that is our vertex buffer, m size, that is our size, so I guess they could use this size as strides, but they decide not to. What's the data size? 4 multiplied by 6 multiplied by 6. Okay, no, that is not. Skybox point, p data, no. Those are not, this is not stride. Sorry. So where do they actually give the strides to the whole conversion? Let's see this. Where is the vertex buffer? It's on the road. Alright, the vertex layout. This has the vertex stride, I guess. Vertex buffer stride. So if you don't know what stride is, stride just tells the uh, graphics card like how many bytes to skip to get to the next vertex. So if you have 4 floating points per vertex, your stride is of course going to be 4 multiplied by the size of floating points. That is of course the size in bytes. So that is the stride. Anyways, that is seemingly what they're doing. I don't think we are CPU bound here, so I am going to do another 4. If we later on just try to unwrap what is wrapped by the engine into our renderer, we would, I guess, remove the overhead because they are doing one unwrapping as well. So if I were to unwrap theirs, I would just do one unwrap, which is just like me straightly directly calling the Vulkan or D3D version and avoiding one for loop. Anyways, for now, I need to declare a vertex buffer class, and my vertex buffer class is going to be, let's see, back to our draw function here. Draw blah blah, where was the draw calls? Alright, here. So offsets, that is offsets, the vertex buffers itself, and yeah, I'm going to call that a vertex buffer. And to do so, I'm going to declare public class here. Vertex buffer. Alright, what my vertex buffer is going to contain is a std uint pointer. Is it going to actually be uint pointer? Let's see our vertex buffers. Nope. Pipeline gender target description root samplers, no, none of that. Buffer then. I don't know what buffer is. Buffer. And maybe buffer ref. I'm avoiding the copy here. And yeah, buffer ref. Maybe not. Maybe buffer itself. Let's see what buffer is. Define aligned. Buffer is a whole object here that I'm risking copying out. Alright. Yeah, we'll figure that out later. Anyways, vertex buffer is going to be buffer std size t my strides and offset. Okay, that looks fine to me. And I'm assuming that this is a container of my vertex buffer. And then I also believe that that part of the code in Vulkan is just wrong. Let's get rid of that. Where was it? Where was that? So I guess this part of the code is just wrong. No upper bound for this. So use 64 for now. Firstly, there is an upper bound for the number of buffers. You just set one. There is one in the iRenderer. You're just not using it here. That's that. Max vertex attributes. So yeah, that is, and there's no sanity checks here either. Like this could well cause uh, undefined behaviors. They would need an insert here, and the insert would be, oh come on, oh no, I accidentally asked VS to build. So that is the same thing to do here. And their comment there, that is just wrong. Their comment here. No upper bound for this. There is an upper bound. Cap buffer count, what is that? Okay, cap buffer count. Max buffers, what is max buffers? Oh god, kill me now. So they're doing kind of sanity checks here, kind of a sanity check. And there is an upper bound for this. That is this, your max buffers. And it's max vertex input bindings. That is your limit. So not only they're inconsistent with themselves, which is this 64 and that 16 we had there, they're actually inconsistent with the hardware. At least they're kinda trying to not cause problems with the hardware. So your GPU would be fine with those kind of bindings, but then again, they're inconsistent with themselves and with your GPU. So your GPU could maybe, I don't know, probably not, could support more than 64 here. Yeah. So they have a proper assertion here as well. They don't have in the D3 version. That is not nice. That was a good insight. I guess I will maybe report these. Uh, so far I've reported few problems with their code. I don't think they've provided me, they've actually read my comments. I usually message them in their Discord. So I don't think they actually cared about my reports. I guess they know these issues. Their design is just bad. So I guess they don't care, maybe? I don't know. Anyways, my job is going to be difficult though. My job would be to actually, I would need a vector here. I'm not going to invoke, I'm not going to invoke any, I'm not going to invoke any pointer. Yeah, I'm not going to invoke any undefined behaviors in my code. They most definitely are going to. I don't know, man. This is just awful. Anyways, ESTL vector, that is the way I'm going. It's going to be buffer pointer here. Buffer pointer, my buffers, and the other, which is going to be studio in 32s. That's going to be our strides. So I believe the Direct 3D interface is actually alright. Like, this is the interface that the Direct 3D is providing. So as you can see, these buffer location, size in bytes, and strides in bytes, these are a single object. That is the design we're going with. So they're asking us to provide this kind of input, then they're packing it in this kind of input. And my input, the input from my interface is going to be this kind of input. I don't know, maybe a, that is a side effect of how they're modeling their GPUs, like Direct3D and Vulkan. That could be partly because of that, because of their model of GPU, their modeling of GPU. Buffers, offsets. And I guess we're going to be pushing them back. Let's reserve this. I believe maybe Clang can optimize this code. Maybe. Given that actually this size is going to be constant, I would probably be providing stud array as my container, and size of stud array is known at compile time. Maybe Clang could optimize this. I know that Clang does heap allocation optimization, so I'm hopeful in there. But yeah, this might go horribly wrong. Also, they're not providing like their interface is not going to allow me to do any kind of inlining. Maybe the optimizer could inline my code to be directly converted to like D3D objects here, but the fact that they're using C files and C interfaces, it is going to completely disallow any kind of inlining unless, of course, I turn on link time optimization and maybe linker could inline it. But I don't think that would provide me with much optimizations. Okay, that's gonna do the trick, I believe. And then what I'm going to do is just call this. The first parameter is of course this. The second is going to be data, no, not data. It's going to be buffer.data. The second is going to be tries.data, and the last is going to be offsets.data. And of course, I'm going to do some kind of static cast here because I'm taking stud size t's as everyone should. That's my static cast right there. And we are done. I guess we can draw now. Can we? Let's try. Let's try draw something. That is 370 lines of render interface, which is going to be completely redesigned. I know much more than I did starting this, so this does need a, a radical redesign, which I partly have in mind. Anyways, let's do our draw function here. So what should we do to draw something? We should acquire next image. So all that it does is this start drawing. And my start drawing is going to give me a graphics command. A reference to a graphics command. So the hell just happened? Graphics command. Alright. So what this does is to this should be down in the submit function, I believe. Present queue, graphics queue, keyframe index, swap chain. Set scissors, set viewport, command bind render targets. Okay, so this part of the code should be executed after submitting. Graphics command submit, blah blah, and then that. Let's see. Acquire graphics command. Alright. So that is going to acquire the graphics command. And then this is going to submit graphics command. So what I'm going to do is just ask the user to just acquire the graphics command, do whatever it wants with the graphics command, and then give it back to me. Oops, I again accidentally asked it to build it. Okay. And then what happens here? G-frame index. What is this? That I believe is this swap chain image index. And semaphore count one swap chain, which is going to be swap chain pointer chain pointer that gets if I remember correctly p swap chain, right? And wait semaphore. We're going to complete semaphore, which is going to be render complete semaphore. Which one is that? Render complete semaphore. That is the semaphore from my queue, which is that. Submit done, blah blah. So let's queue that present graphics queue. This render compute semaphore is part of my graphics command here. Let's see. So the first routine here, this is the routine that happens here. So we just have some fences. We are going to use those fences. Get fences status blah blah. That is happening right here inside our acquire. Swap chain, no graphics command, blah blah acquire command. So that is happening in this acquire command. Let's find that acquire command. I guess I would need to change that name as well. It is simply just acquire. Okay, so our acquire checks this fence here, get fence status, and waits for that fence. So that is this part of the code that happens in that acquire. And then these parts are not relevant really. These are resource loader parts. We haven't abstracted those yet. Then we have begin command. That is, I believe, part of the acquire, maybe? Does anyone actually do that? I don't think so. So that is part of the acquire. So when you acquire a command, you also begin your command. Command pointer that gets. So yeah, that way you require your command, and when you submit it, you should end your command. So end cmd command pointer dot get. Okay, and then you submit it. This is submit procedure, and I believe this part should be inside the submit procedure. Let's see if we actually have everything that we need. So render complete semaphore, we have it. Swap chain pointer, we don't have swap chain pointer here. Swap chain image index, we don't have that here either. So present data. Maybe this shouldn't be done here. So my problem here is I'm not exposing this part from my command here. My graphics command is not exposing its semaphore. And however, I could pass swap chain and image index to this submit function. So maybe I'm better off doing that than exposing my semaphore to the user, because that actually is going to expose my semaphore to the user. So I guess that's what I'm going to do. Swap chain. Uh, swap chain index. That can be const. This is wait semaphore pointer. This is wait semaphore. We have it there. Peer render complete semaphore. Let's see what that was. That is that. And we are implementing this procedure here. So the wait semaphore here is the signal semaphore in here. That is interesting. So I guess what we're doing here is just saying that, hey, swapchain, you're going to use uh, whatever comes out of this queue, alright? But you will need to wait until I signal you. And how am I going to signal you? You're going to wait on this semaphore, and that queue submit is going to signal you to actually start using the result. And this wait semaphore, what does this wait semaphore do? I guess that is just causing the so this queue submit is going to wait on that wait semaphore, which is one in the whole system. That is kind of weird. I'm starting to partly understand this, but not at all in great details. Alright, let's just finish this. So swap chain image index is that, and this is my swap chain pointer, which is going to be swap chain image index. And that is going to be pointer to my swap chain. I'm getting the swap chain reference here. And that should be done. And the user cannot call this submit function, it can actually call this acquire function. That is not good, but it definitely cannot call this submit function because it doesn't have the data that is needed to call this. So still I am not safe on this function here. But I guess this design is not mature enough yet. Let's just get something rendered. We will do the design. Chain signal centerfold, that is correct. This is going to be that. Let's rename this. Script. I'm noticing that you are experiencing some buffering. I only have 8.6% of frame drops. Why are you buffering? Connection seems excellent. And we are 50 minutes in. Jesus. Time passes by so quickly. Yep, we are 55 minutes in. Let's just get a okay, let's redo some parts of this here. So that is going to be swap chain first. Swap chain image index. That's that. This should compile, I believe. So we acquire our command and then we submit it. But what is the reason I'm experiencing? Okay, so my other connection is weak, so that is the reason I'm experiencing some buffering in my laptop here. Okay, as far as I am concerned, things should be fine. Okay, on my draw, I'm going to not const auto graphics command that's going to be equal to renderer. Let's put a reference here. Renderer core graphics command. There goes that, and then we're going to submit. Did we rename this to submit? Yeah, that we renamed it. Renderer submit graphics command. Okay, let's see if this compiles. We are so close to just getting a render. This okay, yeah, it of course doesn't build. Vertex buffer undeclared. Who cares? Oh, that is the assertion I put there. And that is going to be vertex buffer. What the hell? What the hell just put that there? Holy cow. This is semicolon. Yep, you are correct. It does compile. Really? Let's hope it doesn't crash. Wow. Oh, alright, alright, alright. Alright, let's not get so enthused about this. I ran the wrong example. I should run my own. Where's the server? Okay. Of course it's gonna spit some errors. Like, how would I dare say I wrote this code without any bugs, any completion errors? And most definitely have completion errors. Command undeclared here. There's that. Wait, commands are okay. You would be right, sir. Command pointer. And why is oopsie doo bind render target? I believe I'm doing these in a choir, am I? Or am I not? So yeah, let's see. Depth buffer, render targets. Okay. Bind render targets, set viewport. Bind render targets. I believe I provided an interface for this, didn't I? No, I didn't. I'm going to provide an interface for this load action because I do not have the depth buffer here. But then I would need to provide an interface to get the render target for the swap chain, which currently I am not. Swap chain sample count, swap chain format, swap chain quality, no. Add render target. Okay, this needs to be a single. Yeah, this needs to be a single interface on my command. Let me see, let me see. I'm either going to actually do this here, or I'm going to provide an interface for the user. So if I'm going to provide an interface for the user, which I probably should, then this require would be safe to be called by the by the user. Maybe that is what I'm going to do. Yeah. Let's come here. Add one little thing here. Bind that is going to bind render targets, and so load action. So just as we reached the 60-minute mark, my connection just went off. Sorry for the buffering you're experiencing. And yeah, let's finish this. Let's get this code compiled, I guess. Or maybe not. I don't know. I'm gonna work a bit on this, and I'm probably going to finish this stream. Render targets, render target, depth buffer. Specificity. Depth varies, slice, color map slices. Yeah, this seems to be too much work already. That is going to be a lot of work there. So I think I'm going to leave this for tomorrow. We didn't get the render here either. So what my dilemma at the moment is whether I do actually need to provide interfaces for. I'm probably going to provide interfaces for load actions. Uh, let's see how. Yeah, I'm probably going to provide an interface for load actions. I'm going to provide an interface for. I'm not sure if I'm going to provide interface for depth array slice or depth meep slice or even color meep slices. I don't know. So I believe those are the number of meep maps. I believe, I'm not sure. Color array slice, color meep slice. What is array slice and meep slice? What's the difference there? Number of arrays or meeps, is that it? Yeah, I'm going to leave this for tomorrow. I will also do this here. Do this in this do this set viewport, set scissor in this layer of abstraction. For now, I don't see a reason to provide extra interfaces. But that would clear up a bit of my code, so I wouldn't need to do this here and acquire goes to hell. I will ask the user to do the acquiring, and I would just copy this here, and that would be it. So my interfaces are clean now. The only problem here is now that I would need to provide an interface for my swap chain for the user, so that the user can actually access the render target of my swap chain, which currently it can't. So that's one thing to do tomorrow, and the other thing to do tomorrow is to finish the argument list of this. I do not know what exactly I need, but I believe I am going to provide interface for everything. So to provide interface for such thing would be to actually wrap my render target. So each render target would have a render target pointer in it and pdepth stencil. So not depth stencil. Color at it would have an array slice in it, a meep slice, and a render target pointer. So this would be a render target for depth map and several render targets for my colors. That is how my abstraction is going to go. So the interface of this would be kinda simple. Yeah. Load actions, and what about load actions? Let's get into this. Let's get into this code for a second right now. So I believe they're taking multiple load actions. So this is my theory, and this is why I'm digging in. So my theory is that they are using load actions. So this is an array just so that this each load action corresponds to one render target here. I believe that is the case. So let's just see if that is true. Yeah, that is true. So that is render target count. So they're applying these load actions per render target. So this is another part that is actually badly written. Since this load action has a depth action, so each load action actually tells to clear the depth uh, this way, and they have multiple load actions in their interface. That is just bad interface there. What if I set the first depth load action to like clear the depth color with zeros, and the second depth action to clear the depth buffer with ones, and leave it at there? Then what would they do? Would they clear it with ones, or would they clear it with zeros? Depth stencil. So let's see what they actually would do in such case. I'm not sure if I'm clear on what I'm trying to, uh, on the point I'm trying to make here. So they're expecting single load action. Alright, then I was wrong. A single load action, they're always. So a load action object contains multiple load actions and clear color values. Oh god, this is just such a headache. So that is what I'm going to put in my render target. So it is going to be taking render target load action as input, which would contain a render target and a load action. And then I would just reassemble things here for Forge's interface. Okay, that's what I'm going to do tomorrow. I'm going to leave this at that. So this is the second day we're not compiling our code. So like, what could go wrong? Alright, thank you for watching. See you tomorrow.